Here's 17 and 18.
Okay. Thank you. So today we're up into lesson 10. So lesson 10 is going to talk about scales, which we're going to do second, because scales are a little bit harder to manage, I think, and graphs. We'll do graphs first. Graphs, in the way our book does them, are a little bit easier to manage. So basically a graph is just a picture. There's some sort of situation with some numbers and some stuff going on, and a graph is a picture of what happens. So every year I do the same graph, and every year I just kind of go through like the order of the people, and somebody's going to end up with the highest score and somebody's going to end up with the lowest score, but this doesn't reflect like true math. This isn't your real grade, this is just me making up numbers. So if you got the highest grade on this, don't celebrate it because it's not real, and if you got the lowest grade, sorry, like somebody had to, so don't feel bad. It isn't based on any kind of reality, it's just I went in order, the same order I always do when I put the names up. So if we look at this, this is like a mythical story of, we had a test, here's the grades, and the information is organized in this graph. And so I could ask questions like, who had a 70? Somebody with the hand. Who had a 70 grade?
The closest is 10.
Is 10, and we assume that I did my best to draw. It may not be perfect. But yeah, if we look at the 70 line and track across, I'd say, yeah, that was probably 10. I could ask a question like, instead of giving you the number, give you a name. What did Eli have?
90.
90. So we go to him, we track up, we see how high that is. It's more or less 90. If I could draw, which two people had the same score? Let's get somebody that didn't go yet. We've heard from those two hands, yeah?
Avery and Noah.
I would say, yeah, Avery and Noah have the same score. If I actually had the ability to draw, I was trying to make those the same height, so they had the same score. I could ask something like, who had the best score?
Gavin.
That would be Gavin, because his column went the highest. I could say, who had the lowest score?
Samantha.
Okay, so sorry about that, just an unlucky seed, not based on anything real. But yeah, it had the lowest thing. But a graph, they could ask you, this is called an axis, they could give you a word or a number from this axis and ask you to track that way, or they could give you a word or a number from the other axis and ask you to track that way. But that's just a graph. It's a way to organize two kinds of matching information. Anybody have a question about how we were reading that graph? There's like pie graphs, there's line graphs, there's bar graphs, there's a lot of kinds of graphs, but it's always just a picture representing something that's usually not so bad. Second thing we're doing is a thing called scales. Okay, scales are a little bit more to it than that. So I don't mean scale like your bathroom scale that tells you what you got, what your weight is. In math, a scale is more like a thermometer kind of thing, is one way to do it. I've got all these markings. We're trying to figure out, like, where are we in this level? Somewhere in the middle. The low level is 0, the high level is 15. We fell somewhere in the middle. Our first job for these scales needs to be to figure out what is it counting by? Can anybody figure out on this one? What is this thermometer counting by?
Threes.
It is counting by threes. How did you figure that out?
I counted by threes.
And you found that's fine. Yeah, you could go trial and error. You could be like, I wonder if it's counting by ones. 1, 2, 3, 4, 5. Nope. It's bigger than that. Is it counting by fives? I don't know. Try it. 5, 10, 15, 20, 25. Nope. Maybe it's counting by threes. 3, 6, 9, 12, 15. Yep. So that's one way you could do it, is just trial and error. That's true. Anybody have another way you could figure out what that's counting by? Because if it was counting by like 3 1/2, you might never like stumble your way into it. Okay, so let me give you a way we can do this. So one way we could do this is first subtract the numbers. So we'd subtract the top minus the bottom numbers. In this thermometer, 15 minus 0 gets us 50. Step 2, count the boxes. Not the big blob at the bottom where the mercury or whatever it is in that thermometer would be all pulled up, but just count the rectangular boxes. How many boxes are there on this one?
Five.
There are 5. Then we're going to divide. If we take 5 into 15, there's our 3 that you figured out by trial and error. And I'm not discouraging trial and error, just sometimes trial and error doesn't work. Or work well. But we're counting by 3s. So if this is the 0 line, then what we have to do is count up line by line. So if this is the 0 line, this line would be just yell 3, then
6.
then
9.
and then stop counting because that's where the mercury stopped. Question about the scheme on that? Can you turn me a little bit that way because I think the other one is cut off when we get there. So here, let's work through the scheme. So let's go ahead and subtract the top and bottom numbers. We're coming out with, just yell,
0.
subtract them is 30. Count the boxes, but not the blob at the bottom,
6.
6. Then we're gonna divide, makes,
5.
so then we just need to count by 5s. So if we start from 0, we get
5. 10. 15. 20.
25 is the answer. What would be a quicker way to get the 25 once we had the 5? You could multiply, that could work. What's another quick way to get that 25? Instead of counting up from the bottom,
Count down.
count down from the top. We were closer to the top. So you could also count down from the top from 30 to 25. This we could have counted down by 3s to 12 and then we still land on 9. It doesn't matter which way you count line by line. These were a little easier because 0 was the bottom number, made the math a little bit easier. If the bottom number is something else, it makes it just a little bit harder, but not greatly. Again, subtract the numbers. You come out with 20. Count the boxes.
5.
There are 5. Divide gets us 4. So we need to count by 4s. Either start at the 10 line and keep adding 4s, or count at the 30 line and keep subtracting 4s. Doesn't matter to me which way you count. Either way, what are you going to land on that one?
26.
Not 20? Agreed. Because at 30, we count down the first time, that would be 26, down 4. Go down another 4, that's where 22 would live. Or if you come from the bottom, add 4 to 14, add 4 to 18, add 4 more, you're going to land on 22 either way. Why don't you try one without me taking you through the step-by-step? Use a piece of scratch paper or something if you need it. Sometimes people forget the steps. Sometimes they get home and they're like, Mom, Dad, help me. And Mom, Dad, like, wait, do you have any way that the notes that describe how to do this? So one year I did like a sample problem on a piece of paper. Is there anybody that wants to take one of these home in case you forget the steps or parents want a thing to help you with the steps? It's basically just those 4 steps. Never hurts to have a notes paper in case you get home and somebody at home is like, hey, get notes for this. Once you get an answer, raise a hand. I'll put what you think the answer is, and then we'll see if the other people agree or disagree.
23.
Anybody with an agree or a disagree yet? If you're like, wait, what am I supposed to do? First thing you do, subtract the top and bottom numbers. Second thing we want to do is count some boxes, not the wall, but the boxes. Third thing we'll do is divide. We do all that work to just figure out what is the count being done by.
What did you say?
He said 23.
Yeah.
You agree with 23? 2 votes for 23 so far. We'll wait, give everybody a chance. We're in no big rush. Do you have an opinion yet?
I think.
You agree with 23? Sure. Yeah, if you're a phone carrier, just leave it on the silent sheet.
I agree with 23.
Agree with 23? Seems like that's a runaway favorite.
Yes.
23. Still working? Either you'll join everybody else and 23 will be right, or maybe it's not 23 and you'll be the only one. Correct everybody. Reminder, when we're done, we'll be looking to take some quizzes. So if you want to start taking a study minute while we're waiting, that's not the worst idea. There's fraction quizzes for some people, but not everybody. There's metric quizzes for everybody. There's,
Wait.
I think that's what we're done
And
to.
isn't it just me and Noah doing the fraction
doing that.
quizzes?
You're not doing
Oh, wait,
fraction
no, yeah,
quizzes.
the metric
But
quizzes.
everybody's doing some metric quiz.
Yeah.
Everybody's been, with absences, everybody's in a
Aren't I
different
doing
place
the,
right now. You're doing the one that's
The
empty.
blank? Okay.
I'm doing
I
that.
agree.
You're also that one.
I agree.
You agree with that? I agree with that too. Good. Let's just talk through the steps to make sure nobody's fibbing, make sure everybody gets it. So when we subtract the boxes, or subtract the top and bottom numbers, that got us
24.
24. When we go to divide, we've got to count the boxes as
6.
6. Divides gets us
4.
4. So if we add 4, we're at
We're at 15,
15,
19,
19,
and then 23.
23 is what we want to hit. Or if you came down, it would be 31, 27, hit on 23. There's a sneaky way you could do this one because this is right in the middle. There's 3 boxes above and there's 3 boxes below. So here's a shortcut that'll occasionally work if you're right in the middle. Anybody know what you can do to get the number that's right in the middle? It's a math word that you'll know from other years, but might have forgotten it. It's an A word.
Average.
Average is correct. It wouldn't have worked for any of these other ones because they were off balance. There's like 5 below and 1 above, or 3 versus 2, 3 versus 2 again. But since this is 3 versus 3, you could just average the numbers. How do you do averaging? Anybody remember averaging from other years? You'd add them up, divide by 2. So to averaging, you add them up and you divide by however many there were. But there's 2 numbers, add them up, divide by 2, that could work on that. But that's not the main point of today. That's just an occasional shortcut you could use. So homework situation is a little different. We're not going to do a complete book page. The thing I want to get the most practice on today is these, because these are probably a little more challenging than some of the stuff we've done. So I have a worksheet with like a dozen of these, and then we're gonna do a little bit of page 22. But the worksheet will say at the top what problems to do on 22. So I don't need to write that on the board, they're already written on the worksheet. So worksheet plus a little bit of 22. I don't care if you do the 22 just on the back of the worksheet, if you don't need lines. If you like lined paper, you could use your own line paper. Just staple it together if you're gonna end up with like two separate things.